Hello everyone, thanks for attending this presentation. I am Alessandro Altavilla, a PhD student in the computing department at Goldsmiths, University of London. So this is a collaborative work made with Baptiste, Caramiaux and Atau Tanaka, a colleague at Goldsmiths, and Scott Pobiner from Parsons, the new school for design in New York. In this presentation, we present form follows sound, designing interaction from sonic memory, which is a participatory approach to sonic interaction design. Sound has a long history in HCI. It has been used and designed to convey information to a user about events, alarms, and the state of the interaction with a system. In the field of sonic interaction design, sound, and in particular sound feedback, has been exploited to help continuous interaction with artifacts. Designers can explore novel ways of manipulating everyday objects by augmented and interactive sound to action mappings. As a sonic interaction design can help continuous interaction with artifacts, we can also see how we can shift from object augmentation to the body. These give us insight in applications such as motor rehabilitations for health purposes, performance improvement such in sport, and the study of cognition and perception. However, there is still lack of insight for interaction designers and probably researchers in general willing to work with sound and body movement. In particular, there is a problematic on the sound design aspect, what kind of sound we use, what kind of synthesis model we use, we need real sound, synthetic, and as well, how to study action-sound relationship and even how to envision new ones. In our approach, we look at an embodied sound cognition. Sound, in fact, is powerful in a way that can provoke a visceral response and influence action. In cognitive neuroscience, couplings between the auditory and motor system have been reported at the level of the brain. At the same time, the body is not passive in the auditory perception. We orientate our body to better perceive sound and to investigate our surroundings through the act of listening, for example. On the other hand, behavioral approach of sound action coupling have been examined in terms of physical and bodily gestures and how these can represent the sounds that it accompanies. Another important element is to consider the experience in the everyday of sound. And for example, how it's rich and diverse from person to person and from situations to situations. As well, listening is powerful to understand situations we are in and the possible actions that they can be taken in the specific context. We want, therefore, to explore sonic experience for imagining and conceiving a bodily interaction with sound. We use a participatory design workshop as a method, and we try to recall everyday sonic experience directly from the participants of our workshop, and use this as a starting point to imagine infer action-sound relationships. We want to exploit what participants imagine, what they can generate as a scenario of bodily interaction with sound. As we start from sound, we call the workshop Form Follow Sound. In the workshops, we have two phases, ideation and realization. In the ideation phase, we generate ideas for action-sound relationship. We generate them with the participants without the support of interactive sound technology, just finding strategies to describe sonic interaction and to work with that. Sonic experience. In the realization phase, participants create technology prototypes to play out their imagining sonic interactions. We start the ideation phase with the sonic incident. This is a technique that we use with participants to help them to evoke sound-based memories and experience from their everyday. The sonic incident is an adaptation of the critical incident technique from Flanagan, coupled with exercise in acoustic ecology, which are aimed to help students in sound to remember and describe everyday sounds. In the workshop, we ask our participants to remember a particular incident that occurred within the 2 last days, for which the sound was particularly memorable for them. Participants described the sound and the situations they were while they heard the sound. We then ask them to write a text and a graphical description. In this way, we aim to start by sound, considering sonic experience that have a particular critical significance for the participants themselves, as a form of case study for generating design ideas. A second activity is imagining interaction with sound. In this activity, we ask participants to imagine how they would interact through action, through bodily action, with the sound described in the incident and the situation itself. This aims to generate scenarios of interactions based on the incident. We use 2 strategies. As a first strategy, in one of the workshops, we explore participants' action provoked by the sound, by the sonic incident earlier described. In a second strategy we adopted in the following workshop, we use the metaphor of superpower. We ask them to imagine to have superpowers, and through their action with their body, they could manipulate the sound or manipulate the situation described previously in the sonic incident. We ask them to imagine how this happened and what happens. And it doesn't have to be realistic. In the realization, we present a toolkit. And the aim of the realization is to prototype sonic interaction with technology. So we designed and provided them an hardware-software toolkit to realize gestural sound interactions. As hardware, we used the WOX3, a miniaturized 3-axis accelerometer. As software, we use a toolkit that is based on gesture sound programming modules that can be reconfigured by the users, so they can do their own gesture sound mapping. We use machine learning for gesture recognition. In the scenario building phase, participants were grouped together in breakout groups. They use storyboards to develop scenarios using the interactive sound technology that we provide. Finally, in the last phase, participants implemented their projects in working prototypes and presented them to the others.
I will now present you how we collected data and how we analyzed and the result we found from the workshop we did. So we did 4 iterations of this workshop in different locations, and that gathered 43 participants of different level of expertise with sonic and music computing. And at the end of this 4 iteration of the workshops that happens in 8 months' time, we had 12 projects, working projects that has been presented to the other groups. So we collected video data, video recordings of all the activities that Alessandro presented earlier. And we collected also text and graphical representation of the sonic incident, the imagine interaction, and the storyboards created by the participants. And we analyzed that by describing each phase, each activity, and trying to generate categories from the data we collected. So now I will present you the results. So starting from the sonic incident. So the sonic incident, from the sonic incident we gather a pool of sounds that happened to the participants mainly. None of the participants were thinking about sounds that they would produce with their action and their body. All of them were incident sounds. From this, when we asked them to imagine interaction scenarios, we found that we could categorize these scenarios according to 4 categories that I will describe now. So the first category we labeled conducting. It means that the gesture triggers sound. So for instance, the participants were imagining herself in a plane with a baby crying next to her, and she was imagining being able to perform a gesture to make the baby stop crying. The second category, manipulating, gather scenarios where the action of the participant controls acoustic parameters of the sound. So for instance, one of the participants were remembering sound of the wind outside of his place, and he was imagining himself being able to perform some movements and being able to change the loudness or the brightness of the wind. The third category is substituting. So this category gathers scenarios where body movements substitute the sound source. So for instance, participants were imagining himself riding his bike with the duck horn on his bike, and this duck horn was doing some strange sound. He was imagining himself being able to beat this duck horn and to change the strange sound accordingly. And finally, reacting, where here the action was mainly in reaction to sound. So from this, as Alessandro presented earlier, we imagined two tasks. One, in the first task, we asked the participant to imagine the scenario according to the action that the sound provokes, and in the second task, it was the superpower metaphor. So under the first task, what we found is that all the imaging scenarios were in the reacting category. And in this particular configuration, the participant couldn't be able to take what they imagine as scenarios in the reacting categories to implement a working project. They were a bit lost, and they had to come back to the sonic incident in order to build another scenario. So this was the case for 4 projects under the task 1. Under the task 2, which is the metaphor of superpower, where they could imagine an explicit control on the sound, the imaging scenario were more spread in all the categories, and the participant could build a scenario and a project based on the unrealistic imaging scenarios. So this was the case of 8 projects collected. So let me go a bit further in this in the result we have in this particular configuration. So what we saw is, once they were building scenarios and realizing this project, and trying to do the same analysis, categorizing the projects according to the categories we defined earlier, we found that 3 categories remain. That all the projects could be categorized alongside these 3 categories, which are conducting, manipulating, and stimulating, substituting. These three categories were we thought as these 3 categories as interaction models, which means like operational description that could be used to understand how the interaction proceeds. So let me now give you an example for each one of these models that we define. So for the first model, conducting, in this example, the participant will control with that gesture fireworks sounds.
Go like this.
So two gesture recognized, and 1 gesture is associated to 1 sound. This is the conducting model. And now the second model is manipulating. In this case, the action controls acoustic feature of the sound. So this is the case of the wind, where the participant will control some aspect of the wind sound. And in the last case, the substituting model, in this case, the body movements or the body of the participant substitute the source of the sound. So in this case, this is the example of the duck horn, when the participant is putting himself as the duck horn or inside the duck horn, producing the strange sounds. In this example as well, the participants make use of gesture recognition modules in order to realize this application. So, what we from this result, what we saw is that sonic incident, as we define it, doesn't give any constraints on the chosen sound. We didn't ask the participant to find sounds that are clearly produced by actions that will be maybe more easily and then to find some interaction. So there is no constraint on the sound. And interestingly, the second activity where they had to imagine some unrealistic or realistic scenarios of interaction, this activity helped the participant to think about embodied relationship with the sound. And we saw that the importance of the metaphor, where in the case of the action provoked by the sound, they couldn't really imagine this action, while in the case of the superpowers, the notion of control and the realization of this interaction was easier. And then about the interaction models that can be generated by our method, we saw that the models are not mapping. They are not input-output relationship, but they are more models of the interaction. And as an example, we can see that models embed different aspects of embodiment based on the project, the realized project we have, because they have they embed different aspects of tracing acoustic features or producing the sound source coherently with previous research in more psychological field. So to conclude, we presented participatory design approach of sonic interaction design, where the method we propose is based on sonic experience starting from the sound and embodied sound cognition. And we propose models that would be insightful for interaction designer to address sound as an innovative and rich medium for interaction. Thank you very much.
Well, actually, we left the question quite open in the beginning, and somehow they described the only sound that they happened to them. So that this is already interesting to see, maybe to investigate more question about the experience itself. Relating to sound that they will produce, I think it really depends what kind of question and metaphor we use in that phase as well, because even like we notice as well that in our second exercise that has an extreme importance. But there have been already a history of action-sound relationship questions, meaning which the participants were actively produced. And yeah, this is mainly in the literature. However, it would be interesting to investigate more. But yeah,
just to add something, I think what was important here is because the situation was important more than the action in the sound. Basically, is the situation also that afford form action to apply to the sound rather than the sound itself. So that's why it was based on sonic experience as well.
Yeah.